So, hello everyone, welcome to iitiansgateclasses. Am I audible? Quickly, guys, respond. So, you guys might be waiting for this session from long. So, this session is for strength of material. So, guys, quickly, yeah, thank you, guys. So, let's start. So, these details for our 2025 and 2026 support for different courses from IGC for GATE Aerospace Engineering. So let's start GATE 2024 Aerospace Engineering Strength of Material questions. And guys, there are total 6 questions from strength of material, and most of the questions are easy questions, guys. Okay, so let's do one by one. So this is first question, and it is MSQ question, and it is from basic elasticity, or you can say material related question. So what it says: which of the following options is or are correct? So what it says: first option, material properties are independent of position in homogeneous material. So guys, basically, what is a homogeneous material? So guys, homogeneous material is a material where material properties are same across material, or material properties are independent of space coordinate, right? Independent of position. So A is correct answer. A is correct answer. Yes, Abhishek, good. You have done correctly. Read option B, what it says. The stress strain graph for a non-linear elastic material is as shown in the figure. Can anybody tell why option B is not correct? See, what is elastic material mean? Can anybody tell the properties of elastic material? Elastic materials are those material when they are loaded and unloaded, there is no permanent deformation, right? They will follow the same path of loading and unloading, right? That is what property of elastic material, right? But here you can see the loading and unloading are different, so B is wrong. Clear? Now read the option C, what it says. The stress strain graph for a linear elastic material is, you can see, loading and unloading in the same plot, and also it's what, linear. So C is correct. Okay, now option D, what it says: an isotropic material has infinitely many planes of material symmetry. Yes, for isotropic material, what is the property of isotropic material or definition? Isotropic materials are those materials at a point in all the direction materials properties are same. In all the direction material properties are same, right? So that means D is also correct. Means there will be infinite plane of symmetry at that point. Okay, so D is also correct. So for this question, what is the correct options, Abhishek? As you said, A, C, and D. Now, guys, I am asking one question. From today afternoon, 10 o'clock, Abhishek, Neil, others, we are doing this session. Are you guys finding difference between IGC and other institute? What difference you guys are finding? Anybody? I'm asking this question. What difference you guys are finding between IGC and other so-called institute? Loading and loading, Swastik, I will answer your question. Loading and unloading means what? See, whenever any structure is loaded, it will undergo deformation, right? If the structure having, if structure is not rigid, right? So when it undergo deformation, and if the load is removed, then it will come back to original position, right? So that is what loading and unloading meaning means. It will follow exactly the same path without any permanent deformation. See guys, they told like non-linear elastic. You guys know, right? in case of in case of non-linear elastic, also the elastic means it should be coming in the same path, then only it will be elastic. Okay, otherwise that is not correct by the definition of elastic. Yes. Now guys, what is the difference between IGC and others? Explanation and all, Abhishek, is fine. The first thing is consistency, right? Consistency of our work. We taught everything including engineering mechanics, Abhishek. From there, question has been asked this time. Okay, in fact, thermodynamics question also there, right? Always. So the first part, the difference between us and other is the teamwork. You guys have seen today all our mentors, right? It is not just on our website, and we have subject expert for every subject. Okay, in fact today I was not that interested to take SOM session. I thought I was interested to give it to Rahul sir, right? Because nowadays SOM is taught by Rahul sir in IGC, but he's traveling. Okay, second thing, each and every question we will solve as per our best knowledge, not from copying from here and there. Okay, third thing, we keep things as what we are. Sometime solving question on 3D board, sometime solving question like robot, right? Sometimes solving questions like reading on handwritten, sometime solving question like pen and desktop board. We don't do all these. Okay. And guys, some people went to exam hall and they took datas. This is what I am observing. Okay, you all understanding what I am saying? Some people intentionally went to exam hall and taken data. Okay, to showcase. That is what also happened. Actually, it happens everywhere with big institute, but this time in Aero Institute also happened. Okay, but we have solved on exam day what we were knowing from our students. That's it. Today also we are not telling this question is for 1 mark, this is for 2 marks. We don't do all those things. Okay, we know question paper, actual question paper, and we are solving as it is. Okay, so let's move to next question. Yeah, so guys, this is again a simple question, and we have written, guys, right? In IGC we write stress strain relations in matrix form. Okay, so simple it is, guys. It's a three-dimensional stress strain system in a matrix form. And I think prior also similar question they have asked from stress strain relationship, and then they ask some relationship. So earlier I think it was strain to stress form. This time it is stress to strain form. Okay, Neil, that is what the difference. Now guys, if you write a three-dimensional stress matrix, write sigma xx, then sigma yy, tau xy, sorry, it is 3D now, so it is sigma zz, then tau xy, tau yz, and tau zx. So how this matrix is written? If you write, it will be what? It will be E upon 1 plus nu into 1 minus 2 nu. Then there is a matrix. What that matrix, guys? Can anybody tell? What is the first member, Neil, of that matrix? Usual, what is the first member of that matrix? It is 1 minus new, then new, then 0, 0, 0, right? So 3 zeros because it's a 6 by 6 matrix. Okay, then again what it will be, new 1 minus new, then you can write here it is new 1 minus new, then 0 0 0 0 0 0. Okay, then it will be 0 0 0 0 0 0 0 0 0, and it will be what, 1 minus 2 new by 2, 1 minus 2 new by 2. Okay, so it is 1 minus 2 new by 2, 0 0 0, 1 minus 2 new by 2, then 0 0 0 1 minus 2 new by 2. Okay, this matrix is multiplied by what, it is multiplied with epsilon xx, epsilon yy, epsilon zz, then gamma xy, gamma yz, gamma zx. Clear guys, is this clear? Very good, Neil. Now guys, you can compare this given matrix, right? What is P, what is Q, and what is R? Yes or no? With this stress strain matrix, right? So what will be your P? So P will be what? It will be E into 1 minus nu upon 1 plus nu into 1 minus 2 nu. Am I correct? Yes or no? What will be Q? Q will be E into nu upon 1 plus nu into 1 minus 2 nu. Am I correct? Yes or no? And what is R, guys? What is R? R will be, R will be what, guys? E upon 2 into 1 plus nu. Right? So which is nothing but what? E upon 2 in, E upon 2 into 1 plus nu is, guys, what? We all know it is G. Now guys, we have to find which is the correct relation, which is correct among all, which is correct among all. So guys, simply if you write P minus Q, what you guys get? What is the P? P is E into 1 minus nu upon 1 plus nu into 1 minus 2 nu, and then minus. Okay, so minus E nu upon E nu upon 1 plus nu into 1 minus 2 nu, right? This is what P minus Q. So guys, simplify what we find, what we find. If you simplify, what we find, we find E into 1 minus 2 nu upon 1 plus nu into 1 minus 2 nu. So 1 minus 2 nu got cancelled. So we got E upon 1 plus nu. It is what? P minus Q. Now guys, divide by 2. So what it is? What it is? It is R, and this is equal to G. So tell me which is correct answer? Among 4, what is the correct answer, guys? What is the correct answer, guys? Quickly. So A is the correct answer for this question. So guys, this question was easy if you know these stress strain relationships in matrix form, either stress in terms of strain or strain in terms of stress, and all these are already provided in IGC notes, and we cover also in our lectures well. Yeah, so now guys, this question we have solved in memory based question also. What it says: a material has Poisson's ratio nu equal to 0.5 and Young's modulus E equal to 2500 megapascal. The percentage change in its volume when subjected to a hydrostatic stress of magnitude 10 megapascal. So I told guys in prior also, we will not solve this question. Direct away we can answer. What will be the percentage change in volume? Delta V will be 0 here. Why it is 0? Because they given nu equal to 0.5. They have given what? Nu equal to 0.5. That means this is perfectly incompressible, perfectly incompressible solid, right? Perfectly incompressible solid. So guys, for perfectly incompressible solid, there is no change in volume. Okay, you guys can check also. If you try to find volumetric strain, you will get 0. Okay, so the answer is 0. How it is 0.5 will not change, because we know what bulk modulus k. K is what? E upon 3 into 1 minus 2 nu. When nu is 0.5, k will become infinity. Okay, so you guys can directly answer it as 0. Next question. Yeah, so this is one of the truss question. Okay, or you can say it's a frame structure. So it's again a easy question. In the figure shown below, but most of the people have not answered this question, I believe, by seeing this. The magnitude of the internal force in the member BC is, okay. So guys, they asked what is the force in BC. So guys, to find force in BC, we can simple do what? We can simple do the moment equilibrium about point A. Okay, the moment equilibrium about point A. Okay, so what all moments will be acting at A? So one will be like this 100 Newton. So if you resolve vertically, what will be the component? It will be 100 sine 30. Okay. Now guys, in member BC, suppose your reaction is what? FBC. Now this is 0.5, this is 0.5, so angle will be 45 degree. So this will be 45 degree. So what is your force in horizontal direction? It is what? FBC cos 45. You can say it is cos 45 degree. Okay. Now guys, simply if you find sigma MA equal to 0, you can do that, right? So if you do sigma MA 0, this force having what is the momentum? It is 1 meter. So you can say 100 sine 30 into 1. Okay, it will give what? It will be giving me clockwise moment. This force FBC cos 45 about this point A, if you take moment, it will give me opposite moment, so it will be equal to what? And and there is no other moment, right? So it is FBC cos 45 into 0.5. So guys, if you solve this, your FBC, FBC how much come? It will coming as 141.4 Newton. Clear guys? Anyone have any doubt? This is the simplest way to solve this question. Now you can see this horizontal component of this force will not create any moment about this point. Same way, the horizontal component of FBC will also not give any moment about A. Right? And the force which is passing through B will not create any moment about it. So this is the another approach to solve this question. How we can solve in today's prior session, I have informed. We can solve in another way also. How? You can consider there is a vertical component which is what, F sine 30. Okay, now you can apply one reaction here and another reaction here. Then you can solve as a beam problem. Okay, so what you can see, this is RA and this is RC. So you can write RA plus RC will be what, F sine 30, and then you can also take moment equilibrium sigma ma equal to 0 due to this load, these two reaction. From here you guys will get RC equal to 100. Okay, you will get RC equal to 100. Okay, so guys, once you know the RC, you can find, okay, the load in this member. Okay, so again you will be getting from this your FBC will be 141.4 Newton. Okay, so that's how we can solve this question. Now guys, the last question, not last, there are two more questions. So what it says, question number 42, the figure shows plots of two yield loci for an isotropic material where sigma 1 and sigma 2 are the principal stresses, sigma y is the yield stress in uniaxial tension. Which of the following statement is or correct? So guys, we already know these are the pictorial or graphical representation of theory of failures. So we know guys, for Tresca's theory, this is dotted is what, your failure criteria pictorial view. So this dotted one, which is what, Q represent what guys, Tresca's criteria, and this oval represent which is what, which is P represent von Mises. So C and D is correct. So for this, C and D is correct. Okay, so let's move to last question, which is question number 44. It is again simple questions from basic elasticity. So read the question what it says. The state of stress at a point is caused by two separate loading cases. One of them produces a pure uniaxial tension along the x direction, and other one produces a pure uniaxial compression along y dash direction, as shown in the figure. The sum of the maximum and minimum principal stress for the resultant state of stress caused by the both load acting simultaneously. So guys, such question is there in Maxon guys. Okay, so here if you add 1 plus 2, there is no shear in given orientation. So you can see the resultant of these two is what, there is one tensile load in this direction, and then there is a tensile stress, and then there is a compressive stress in this direction. This is x1 direction, and guys, this is what, y1 direction. Now guys, you can see here this angle is 45 degree. So guys, if there is no shear in this orientation, that means these given stresses are your principal stresses. So your sigma 1 is 10 and your sigma 2 is what, minus 10. Now they ask summation of this sigma 1 plus sigma 2. So you can see 10 minus 10 equal to 0. Neil, you should have done this question. I think you have skipped this question. It was very easy question. Now, guys, this orientation is corresponding to what? It is corresponding to pure shear case, guys. In case of pure shear, your principal stresses sigma 1 comma sigma 2 will be what? Plus minus tau, if tau is your shear. Okay, or if it is a sigma or p, what will be your theta 1? It will be 45 degree. Clear? So 0 is the answer in this case. Okay, so I think these many questions they asked from strength of material, and you guys can look into all these details. Okay, so thank you all guys for joining this session, and whoever watching this session can follow us on social medias or can join our telegram group for further details. So guys, next session will be engineering mathematics in a while. Thank you guys.